Morning, everyone. Welcome to another fireside chat with the experts. We are here today with Griffin Lemaster, our wonderful COO. He's going to be talking to us today about robots and cobots and how they can be used to augment your X-ray inspection, supplement your workforce into a safer environment, things like that. So we have a really good presentation here. I'm really excited to hear what Griffin has to say. You take it away.
Thanks, Dave, for that warm introduction. As Dave said, my name is Griffin Lemaster. I'm the COO here at Creative Electron. And David, you can see the presentation, right?
Yep.
All right, perfect. So today I'm going to be talking about robots and cobots, the good, the bad, and the ugly. So just kind of a quick rundown. I'm going to kind of go over a little bit of the history of robots, where they came from, why we're using them, get into the differences between the different types, discuss the differences between robots and cobots and everything else that's out there. And also then hit on how we use them in our industry in X-ray inspection and what we're currently doing with them, and and then we're going to touch on some of the advances that are coming up here in the future. Some really cool stuff. So without further ado, let's jump right in. In the beginning, right? So robots have really been a science fiction concept since really the earliest records of humans, going from the ancient Egyptians, the ancient Chinese, that they all left their depictions of automata and other inventions that resembled human and animal likeness. So the myth of these creations really has transcended the generations, right? And produced itself in all forms of entertainment that we see. So you see the picture on the left, that's Talos. He's the towering bronze statue that protected the island of Crete from invasion from enemies. And then on the right, you see one of the more famous robots from cinematographic history, the robot from the movie Metropolis in 1927. Really cool special effects they did back then for not even having computers. So if you haven't seen it, it's worth a watch. But for the sake of understanding this fireside chat and us all being on the same page, we're going to get away from the whole sci-fi concept of robots and humanoids, and we're going to stick with a very simple definition, and that is going to be a programmable device used to perform one or many tasks autonomously. And this is really just I don't want to convolute the theory of what we're talking about with simple motorized mechanisms or remote control devices. These are not simple machines. These are programmed and to do a certain set of tasks or a certain set of movements without consistent human intervention and human interaction to control these. And so they're operating on their own. So why robot? Why have robots become so popular? Why are we using them as much as we do today? It's really, it's been an industry demand. So different industries, automotive, as you see the image there, that's kind of what we think of when we think of industrial robots, is this automotive robot going together and putting cars together on an assembly line. And that's a really good, explanation of why we are where we're at with them. It's dangerous working conditions. It's repetitive motions, repetitive tasks. It's very high speeds and very highly repeatable and precise movements. And these are tasks that we as humans aren't suited for. We can't do these by ourselves. So we essentially, robots, these industrial automation robots, were created to fill this lack of capabilities that we have of humans, and to add to it. So kind of getting back a little bit to the history, where industrial automation started and where it came from. So back in 1937 is really the first modern programmable robot. That was built from toy parts. They were the inventor of the Meccano toy sets, created this first robot. Meccano was like erector sets, but just a little earlier. But what he did was he built essentially a crane-like structure that had 6 different degrees of freedom and running off one motor, and it was programmed by the the paper with hole punches, which really became synonymous for programming for a long time afterwards. And so they kind of really paved the way for a lot of future programming, a lot of future robots. In 1960, there was the first digitally programmable robot sold to GM. And so the purpose of that was to essentially lift really heavy metal castings, hot metal castings, and stack them. And so not a complicated process, but something that really operators couldn't do on their own. And it, it's automated a process that didn't need to have intervention. And so we see this, entrance, this really start of industrial automation come through the automotive field. So in 1996, the first Cobot was invented. And so that was, we'll get into a little bit more about what Cobots are and what that means. And then 1998 to the present, we're in this current robotics boom. And so over the last 20 years, we've seen essentially a 600% increase in annual production. So just massive amounts of robots that are out there doing industrial automation. And it's really driven by the automotive market, but really close behind automotive is electronics manufacturing. And so, this boom is really being driven by a couple key select markets led by automotive and electronics, and doing lots of for different reasons and different tasks. So these applications within these markets. So automotive, it's doing some, it's doing some rough and dirty work, right? You're doing welding, it's doing grinding, it's doing lifting castings, working in harsh environments. But when we see what we see in the electronics industry, is really doing a little more of the finesse of the electronics market. So pick and place machines, if you're not familiar, is machines essentially put every single component that's on a circuit board, populate that circuit board before it gets soldered. And so it's doing very fast, very precise movements over and over and over. And so it's a very high finesse application, and then very quick. And then essentially after the circuit board gets soldered, you have this quality inspection process or automated optical inspection or automated X-ray inspection, AXI, where you're doing a quality inspection after the fact. Cameras moving around, taking images, looking at the solder joints, looking at orientation and the alignment, things like that, and basically making a pass-fail criteria on that, and then doing whatever it has to pushing that down the line to the next process. And then also simple like product handling, right? It's lifting, it's twisting, it's inspecting, loading and unloading. So that's kind of a big difference between automotive and electronics. And then medical is this whole other beast. Really, there's a lot of new advances coming out of this robotics push in the medical field. So from diagnosis, essentially using CT, CAT scan. That's a diagnostic robot, right? And treatments, and even medical device manufacturing. So let's get into this second definition, the Cobot. The Cobot really is it's a collaborative robot designed to work with humans in a shared workspace. So it is a robot, but it's equipped with a unique set of capabilities that the robots really don't have, and almost a limitation at the same time. So now that we know the definitions, you guys are, you're all set and we're good to go, right? Well, of course not. Probably brings up more questions than you had before. How do you know which to use, Cobot or robot? Is it just color preference? What if I don't like green or yellow? Is there other choices, right? So let's highlight some of the key characteristics of the differences between these robots and Cobots. So let's start with the Cobot. The good. I call this one the good. Because Cobots, they're designed to work in the same workplace as humans, their motion is highly regulated. So they don't move as fast. They have sensors built in to sense any type of small collisions or interference. And yes, the colors on the robots are there for aesthetics, to make it seem a little more appealing and less intimidating. Same with the corners. They're all rounded and curved. Even the material that they're built from is a little more lightweight because it experiences less forces and less acceleration than a standard robot. And these are, so the robots are your characteristic they're bound by the classic traits of being a good guy, right? They are no frills, but they're gentle and they love their mother. I mean, it's a safe choice, if you will. Because there's this option for human presence and interaction, there's also a lot less restrictions and operational requirements. So you can walk right up and deliver a tray of parts to a Cobot, and you can even pat it on the shoulder if you want, and the Cobot will load the parts, pick up a part, orient it the correct way, load it into the system, and the system will take it and do whatever the next step is. Because they interact with these humans so regularly, you can do that. If it was a robot, however, there's a lot more restrictions on essentially what you can do with a robot in this right space. So, I mean, for smaller companies, possibly that have don't have as much area to work with, or they don't have as many resources to work with, Cobots are actually a pretty good option to get into this robotic automation, because it doesn't require a set of extra conveyor belts to load parts. It doesn't require all these interlocking fences around the robot in order to work in a safe environment. So let's go to the bad, the bad boy robots, right? These are, like I just said, these are your bad boys. They're fast flying, do or dying, drop them off and leave them crying. They are tools for industrial automation with a capital I. Robots, they're there for the grunt work. They do your heavy lifting. They do grinding, welding, extreme speed work, and these are all things that we need in these rugged, tough production demands. They can operate at the bottom of the ocean. They can operate in an 800-degree environment, and so they're just built tough, right? But one of these limitations of working with robots is it really does have to be protected from human presence. You have to build interlocking fences so that you can't really, get hit by one of these things, because if it malfunctions in any way, shape, or form, or usually it's human error that goes and bypasses an interlock or gets in the way, these robots have enough power and enough speed to do some serious damage or even kill a person. So, talked about the Good-Cobots and the bad boy robots, and both of these are standalone devices used very commonly in industrial automation. But under the skin of even more automation platforms out there, you typically find these in-house creations. That's why I call them the ugly. They're not as polished, they're not as clean, they're not as refined. But these in-house creations that do a limited number of tasks, right? You build them for your task that you need them to do. But they usually do these really well. And I'm speaking about, every widget maker, every thingamabob winder that all uses arrays of electric motors, pneumatic cylinders, conveyor belts, PLCs, and too many sensors to count. So these are ugly creations that really make the masterpieces that we build. And really kind of the backbone of industrial automation. I say inexpensive because you're not paying for all of the, you're not paying for a robot that can do 300 things. You're building a robot that does one thing very well. And another thing is it's self-controlled, meaning you're running this on your own PLC code. You don't have to learn a new program to interact and control a new function in automation. That's with a off-the-shelf robot. So, X-rays and robots. And if you guys haven't gathered from my enthusiasm, maybe I don't give it off very well, this job is really cool, right? Working with X-rays and robots. So how do we here at Creative Electron employ the use of these robots? Well, any way we possibly can, anytime we can. Why not use them if the potential is out there? So depending on the task, we can utilize any number of robots to fulfill the requirements of the project. Off-the-shelf products or in-house creations, all of these will work. We at Creative Electron, our expertise is in cabinet X-ray inspection. If a customer has a product that they need inspected for process verification, or they need to do final test quality inspection, or even reverse engineering, we can build a system that essentially meets the requirements. And one of the key drivers that enables us to serve so many customers in the non-destructive field is our flexibility and our ease of which we can deploy new solutions very quick. And, you know, robots have been a big part of this. Robotics, automation in general, has been a big part of us and able to serve so many clients and automate a inspection process. So inside the X-ray system, we put robots there really because we can't be there, right? It's a dangerous environment. Everything in the cabinet is exposed to high levels of radiation from the X-ray. So we need something moved and manipulated inside of the X-ray system. Robots are ideal for this type of automation. It's a dangerous environment. We can move at really high speeds, and it's repetitive motion. So this is a video shows a SCARA type robot inside a customized TrueView Prime X-ray system designed for ball inspection. The X-ray source is there on the left, and that big dark circle is the image intensifier on the right. What the robot does is it goes and picks up a ball, brings it up, takes an image, rotates it 90 degrees, takes another image, and then basically the computer will analyze those X-ray images, classify the ball, and the robot will take that ball and then drop it off into one of the classified, designated locations for the results of that analysis. Now, the video I'm playing here, you're watching at about 1/3 speed, and that's just so you can actually see everything that's going on. And even through the Zoom, I don't even know with the lag if you can see well, but it's it's essentially doing one of those every second. So it's going very fast. And this customer required that this inspection be done in a certain cycle time. But even though this movement is, like I said, it's moving very fast. It's small movements. It's not moving that much. It's lifting up a couple inches, left or right a couple inches, and that's it. But with those speeds that it's working at, it could really still do injury to a person. And so that's why we have to, keep those interlocks, keep it working in a safe condition where humans can't get in the way of this thing. So this application now, it shows essentially another version inside of an X-ray system. It's a medical device being X-rayed. It's a good example of the ugly, right? So it's a conveyor belt that brings the sample in. Then the device is imaged. The image is analyzed by the software and either rejected or passed based on either operator saying it's good or bad, or we can actually define these programs to use the software capabilities in-house that we have to write algorithms that will define whether it's a good or bad part. This one, if it passes, it continues on. If it's rejected, it gets pushed off the conveyor belt into a locked reject bin further down the line. So as I just mentioned, a major part of this automation robotics process is this X-ray analysis that we can perform. So big part of robotics is obviously feedback, what you get when it gets a signal to tell it to do something else. And so one of our major drivers for feedback is this X-ray image analysis. In our case, it often comes down to, well, after the analysis, you have a classification, right? And so we can do this all in-house using essentially the technology we have to develop AI algorithms. And if you watched the fireside chat we had last week, JJ did a great presentation on the AI that we're developing, and he's really the expert on that stuff. I'll just tell what I think it can do, and hopefully it's right. He'll correct me if I'm wrong, I'm sure. But essentially, every sample that runs through our system, every image we take, builds into this model. And as more images you get with more variance, the better performance this model has. It can perform at a higher precision or at a higher confidence when it makes those decisions. The more samples it gets and the more it displays. And so it's really, it's a cool thing that we're interacting both these breakthroughs in AI and all these new advances in robotics too. It's really given us a lot of bandwidth and depth of the customers and the markets that we can serve. Here's an example of a Cobot operating outside the system. So this is a simple loading and unloading exercise. This is a rendering, obviously. But as the cobot will be interacting with the automation of the X-ray system, it responds to events happening within the system. So further autonomy would then allow the cobot to make adjustments while placing the sample, efficiently. So if it's getting, feedback from the analysis that says, it needs to be moved or needs to be twisted or rotated, the robot can actually feedback and make those adjustments on the fly autonomously without people coming in and checking it. Now, this is one of those cobot examples where, the operator can just walk up, place the sample tray down, and the robot can load the parts from there. You don't have to fence it off. Or if this was a robot acting there, you'd essentially have to put a fence or put other forms of automation that would deliver the samples to the robot for placing in the system. There's another example, simple example of playing. This is a video of basically a low-speed application of unloading and sorting. After the sample is imaged, it exits one of our custom inline TrueView Prime X-ray systems, and the robot will pick it up and sort it based on the analysis. So this is a low-speed application. So in that effect, you could use a cobot in place of the robot we have, if, for example, you can't create that fencing or you can't prevent human presence from being in that area. And so, there's this common fear that robots will one day take over the world and control all the humans. I can't predict the future. I really don't think this to be true. From their origins, really, robotic implementation is rarely with the intention to replace human capacity, but instead really to increase our capabilities, whether that be sorting 1,000 boxes in 10 minutes, working in an X-ray chamber, or lifting a 800-degree aluminum casting. But every day, our lives are touched by these new advances in automation and industrial automation. Science and technology improves, so does this symbiotic relationship between humans and robots. For example, in the medical field, miniaturization has led to crazy breakthroughs in biological tiny robots. Already, microbots are being used to interact with multicellular organisms, and nanobots are, sometimes popularly referred to as nanites. They're currently being developed to essentially track and trace the movement of substances throughout our body, as far as drug delivery goes, and how things work, physiologically within our body that we've never seen before. And even to the fact that I know it's not in practice yet, but they are working on, these nanobot cells to replace white blood cells. So for people with immune deficiency issues, they can, inject nanites, if you will, and these nanites will be able to actually, work on infections and where the human body can't actually fend for itself. So some really interesting and cool stuff coming out from the medical side. In agriculture, there's been robots plowing fields for a while now, autonomous vehicles going around and, harvesting crops. But they're also doing other things. They're doing, they're doing sorting of the crops. They're counting the crops. And there's even weeding robots out there toiling away in the fields. So it's neat to read about this stuff. In education, I read a very interesting article last week that's very, it relates to what we're all going through right now with this pandemic, is that if you have kids, then you're at home trying to teach your kids, where there's a lack of a teacher, and it's really tough. So the funny thing I read in this article is that these robots that are actually working on teaching children and teaching them lessons is that they can repeat the same lesson over and over and over endlessly, and the robot doesn't get frustrated, and heck, it even encourages the kids. And so they're pretty neat what they're coming up with and what they're doing there. And so in industrial automation, where we're sitting, our sector, we're always looking for ways to add capabilities, and we do that every day, every time we build a new system. So we're not just adding capacity. We want to do things faster and better and do it more. but we won't all lose our jobs to robots. Uh, that's sort of this myth. But I can guarantee you there will always be jobs to fix them. That's not going away anytime soon. So with that, that's the brief wrap up of this fireside chat, and I'd be happy to answer any questions you guys have.
Awesome. Thanks, Griffin. We just have a couple of minutes. There's several questions that have come in, but we'll answer what we can. One of them is there any danger to the robots inside of our X-ray machines due to the radiation?
So generally not. The robots we're using in our systems are for rugged use. They are hardened steel cases. The electronics, most of the electronics that actually control the robots are far outside of the radiation field of view. Really just have mechanical parts that are moving inside the robot. So no, there's no danger to the robot, the mechanical parts of the robot. There are very sensitive, chips out there and electronics that can be affected by radiation. But if there are some in the controllers are way outside the radiation area, so it's not an issue.
Okay, good. Another one here. Can a Cobot pick up items that are in disarray, or do they need to be organized in a bin for it to?
Good question. That depends on the capability of your Cobot. There's several different models out there that can do different things. If you throw scatter a bunch of parts on a table, but they're all the same part, obviously there's not a problem. You can use cameras to find where the parts are and load them. And at the same time, even if they are different parts and you need to pick out the right things, if you have enough sensors and enough cameras located on the robot and your software is able, and you have a software that enables it to detect what's what, or you have some method of feedback to determine where a part is, then yes, it can pick up individual parts from different locations. And it'll just need a different type of end of arm tool to do different tasks, whether it's a grip or whether it's suction. So it could use any of those types of methods.
Okay, so that's really a discussion on a case-by-case basis, right?
It is. It's very specific to the task at hand, and there's hundreds of different end of arm tools that they can put on these robots, including in the software that goes into them, behind them. That's a whole nother field. It's incredible stuff.
Yeah. Of course, the cost factors of the two different options, right? Is it going to cost a lot of time and money to put in an organized bin, or is it going to cost you a lot of time and money to pick up a disorganized pile, right?
Sure. And obviously we are, as managers, we always answer that question. We always ask, is that going to be more effective if a person did it or if a human did it? How much do you have to pay them? What's the risk to them? What's your liability for having a human doing it versus having a robot do it, and then versus the cost of implementation? So we all do that cost analysis, and that's part of our jobs as engineers to figure out what can be done. If a robot can do it, you still have to perform that cost analysis, because if it's a very complicated process, it will be a very expensive robot, and it may take a lot of maintenance to keep it running. Most industrial automated robots out there, they're built rock solid, right? So if they're being operated within their limits, they're going to run for a very long time.
Okay, well, it's been half an hour, so that's all the time we've got allotted today. Thank you very much, Griffin. Really appreciate this. It's been really pretty cool to watch and learn more about these robots and Cobots. Well, thank you all for joining us. If you have any more questions, definitely email us at the email here on the screen, info@creativeelectron.com. Look forward to seeing you here next week. We have a good presentation by Dave Phillips on getting the best use out of your legacy X-ray machines. So I hope to see you next week.
Thanks, everybody.
Creative Electron.